Hey guys, today is just the start of another video series. This is the Linux video series, Linux and Unix. I've already installed kalilinux on my PC using VMware. You can do that too if you want. All you have to do is go to kali.org, and then once you do that, you just have to go to downloads, and then you just download the option that says the VMware with the VMware. So download the one with the VMware. It's like 2.4 gigs, and then you have to go to VMware, the website VMware. So just Google VMware, download the workstation, and then you have to unzip the Kali download from kalilinux. Unzip that from your downloads folder into a file on your desktop named Kali. Then run the VMware workstation, and then you just have to find the file that you downloaded and it'll run. This is the one way you can do it, or you can just, if you're using Windows, you can download Ubuntu, it's not that good. The one on Windows, honestly, it's pretty much nothing. You just have the terminal, but it doesn't seem like it's like the best way to use it. But to do that, if you really want to, you can set it up by going to, on your Windows machine, go to Control Panels and then Programs and Features. Find that on the left menu. Then click on Turn Windows Features on or off. And then once you get there, select the checkbox. Select the checkbox on the Windows subsystem for Linux checked. So Windows subsystem for Linux, make sure that's checked. And then you have to reboot your PC. And then after, go to the Microsoft Play Store and download Ubuntu. That's one way you can do it if you just want to follow along with the videos. I recommend using the kalilinux distro. It's better. It's way better than the app. So once you do that, you can just click on the home, the kalilinux button in the top left, and then click on the. You might have to do it in root terminal, but I've already downloaded it, done some of the commands. So if it doesn't work, just try it in both. So I'm going to click on the terminal emulator to use the command line. So for us to write code in C, we're going to have to download some stuff. So just type in sudo su, so sudo su. Oh yeah, sorry, when you download this, the password is Kali and the username is Kali by default. Okay, so once you do that, so sudo su, enter your password if it's asking, which is just Kali if you're using kalilinux. And then here, just type in sudo apt update. So I've already updated it. If you haven't done it, it could take a little while, like maybe a couple of minutes. Excuse me. So then type in after that sudo apt install vim. That's the text editor to write the code in. It's not the best one. It's just what the one we're going to use. The one that comes with Linux. It might already be installed, so just try that. And then after all that, you're gonna need the GCC compiler. So you have to type in sudo apt install install space GCC, and then space dash install. So I already have it installed. So it should be, so just do that if it doesn't work. Actually, sorry, you know what? That's the wrong command. So it's sudo apt install, just GCC. So I already have it, so it should be done. For you, it might take a while if you don't have it. Okay, so now we're going to open the VI editor, or it's VIM editor, VI editor is the same thing. So what we can do right now is just, you can type in the command ls to, it prints the directories and files in your in the machine, in the Linux machine. So it prints all the files and the directories. The command pwd prints the current working directory. So it just tells us we're in home. We're in the home directory. That's pretty much all we need right now. We're gonna need to make it. Well, we don't need to, but we can. So we'll type in mkdir, the command, and I'll just type in C codes, like C and then C codes. That's gonna make a folder, or it's not a folder. It's called directory in Linux. So it's gonna make a directory. So mkdir means make directory space and then the file name. So it'll make whatever file name directory you call. Hit enter. So now you can see we have a directory called C codes on top of our desktop, documents, downloads, music, pictures, public, templates, and videos. So those are all the directories. So after all that, what we can do now is we can open the VI editor and we can create a file name at the same time. So you can say VI, and so I have some codes that are going. That's basically it was a coding assignment for my class. So this is a C tutorial as well. So what the code is the codes are basically they're just different loops. So one is a for loop, one is a while loop, one is a do loop, and one is a go to loop. And then we have an array code as well. So let me just tell you what the assignment was. So the assignment was to let me just find that, sorry. Just opening up. Okay, so the assignment was, so using the C programming language, write 4 versions of a function that contain a loop. Each function should accept 2 numbers and calculate the sum of all numbers between the first number and the last number, inclusive of the first and last number. So the goal is to try to use the same number of variables and almost the same logic when writing the C code for all 4 functions. Once each function is written and tested for correct output, generate an assembly language version of the function using the command, which we'll discuss after. So I wasn't going to make this into an assembly language tutorial because honestly it's very hard, to be honest. It's like hard to understand if you're just starting. They squished it into the end of my class without even a proper book, so I think me teaching it is just going to confuse people, and it's like a lot of the assembly code that you generate with the GCC has macros that are hidden, so it's kind of confusing. But what we're supposed to do in this assignment also is we're supposed to analyze and compare the assembly language version of each function. So we'll save the object or the assembly object files separately, and for each one we'll identify if Is the assembly language version of each loop function the same or different? If different, identify the differences. Your comparison should be based on number of registers used, number of jumps or iterations, and total number of operations. So we won't be able to do all that in one video. So we'll probably just start with writing the first code and just maybe generate some assembly code for that, and then maybe just stop it there for now. So we'll do one, and maybe we'll do the other ones after. So to do that, we're going to create a file with the vieditor command. So I'm going to name it something based on basically just based on my code for this assignment. So there's 4 loops. So do we want 4 separate files? I guess so. So what we're going to do is we're going to have the first function. So what we're going to do is we're going to call this one for function. So we'll say vi. So we'll call we'll call the vi editor. So vi, and then we'll just call it for function .c. Here we go. So now it's open. So yeah, this is going to be an introduction to the vim or vi editor as well. So it's like, well, why do we have to learn all this stuff? Well, it is important because this is where you can write stuff in Linux. So there's basically there's 2 modes in here. There's insert mode and command mode. So right now we've kind of moved into the vi editor. Well, we have moved into the vi editor in our file name. So we moved into a C file, which we're displaying with the vi editor. So basically, vi itself opens the vi editor. Vi space file name opens the vi editor with the file name. So there's 2 modes in the vi editor. Command mode is, to get into command mode, you press escape, ESC, top left corner of your keyboard. So right now we should be in insert mode. Okay, now we're in insert mode. If I hit escape, it's going to go back into command mode. So if I hit insert mode, it means we can write in our text editor. Sorry, just give me 1 sec. I'm just going to put something on my computer because it's getting kind of hot. 1 sec. Let's put this plastic mat thing. Give me 1 sec. I'll be right back, sir. Alright, apologize about that. Just had to put something underneath my computer. So what we're going to do now is we're just going to, I'll just explain some of the vi editor commands. So basically, :W in command mode, that saves the work, or saves the file. :W file name, like for example ours was for function.c, that'll save the file that you want to specify. :Q quits, so that's in command mode. We're in insert mode. Remember to go to command mode, you need to press the escape button. To get into insert mode, you need to press I. So we have :Q or shift:"Q. So :QL quits without saving, so it doesn't save. :WQ or shift:"WQ saves and quits. So we can write code in the VI editor such as C, Python, Java, whatever. So now what we can do is we can write the actual C code now. There's a few more commands to execute the file itself, which we'll do at the end. That's pretty much it. That's the gist of it. So now you can say that you know Linux. Pretty much if you can move the directories around and do the commands, like memorize the basic commands, you pretty much are working with it. So it takes a while to learn something, obviously, especially like an administrative language. You just have to practice it. So at this point, what we're going to do is we're going to type the actual code now. I prefer to use an IDE like Visual Studio, or not for C. For C, use JetBrains C-Line. That's the best one, to be honest. It lets you step into all the functions properly to debug. The debugger is better on C-Line than it is in Visual Studio, but we'll talk about that later. So here we're going to have our function, basically our file name. So we're going to need to include stdio.h. So I believe we are in insert mode. It says that at the bottom left, in the bottom left corner. We might need bool too, so include stdio. Actually, no, sorry, stdbool.h. So .h is a header file. So we probably need to prototype it. That's going to be a pain later on, isn't it? So if I want to go here, okay, you can make spaces. Okay, so that's fine. So we'll do it later. So we have I don't want to put all these files together. If we do that, will the assembly code itself be visible? That's what I'm worried about. Actually, you know what? We're going to try doing it this way, in one, because I think doing it in a bunch of files is going to be confusing. Or we just have one file and we can generate all the assembly for that in one file. So at least start with the first part. So we have this. I didn't want to call it this, but that's okay. So we'll just stick with the name. I was going to call it main, but that's fine. So what's really happening is we're going to have all the functions and all the loops and everything in this file. So we're going to need a void main. Okay, so in void main, we can leave it empty right now. Below, we're going to have another function. So we'll have void return type, call it for function. Hopefully it doesn't get confused with the same file name. If not, we can just change it after. So again, it takes two parameters. So we'll take an int val1 and an int val2. So this could take a while, to be honest. So we're gonna have this video could be long. So we have int current val. We have int current val2. Sorry, hopefully just to let you guys know that the mic quality is good, because I had to use my laptop because actually I didn't have to use my laptop in this case. Alright, so that's fine. So I'm using it on my laptop at this point. As you know, well, I don't know if you know, but I usually do videos on my PC with a wired mic. The quality seems to be better. This time I plugged in my Ethernet into my laptop just to see if that would help with the quality. But for now, we're doing it with this. Next time, if the quality isn't good, I'll move back to my PC. So just a heads up. Hopefully it's good enough to understand. I'm using a Bluetooth mic because if I plug in the mic to my laptop, you can hear the fan, so it's kind of crappy. So hopefully you guys can hear. So we have our two int variables, current val and current val2. We're going to need a current sum, which is also an int, so int current sum. And we'll need a boolean, so we'll call it first pass, set it equal to false. And we'll have second pass, sorry, with a bool. So bool second pass points to false. So here we'll have a for loop for int I is equal to val1. It points to val1. I is less than or equal to val2, I plus plus. Right, so we have our loop, and then inside the loop we're going to put square brackets. So we can have this whole loop execute everything in the brackets every time it loops one iteration. So we'll have if first pass is equal to false. Then we'll say current val points to I. So I'm kind of looking at this with like on my phone, so it's all the text is like jumbled, like the code's all spread out weird. So I'm just trying to read this properly. So we have our for loop. So for so we have our for loop if first pass is equal to false, current val points to I. Looks like we're still in the loop here. So we said if first pass is equal to false, current val points to I. So then we have first pass. We'll set that to true. So first pass now points to true. But outside the if. Nope, that's inside the if, sorry. First pass, so we have if, open bracket, current val points to I, first pass points to true. Okay, sorry. First pass points to true, semicolon, close that if, else, clause, open square bracket. I'm just going to close it because it doesn't do it automatically. So else if second pass points to false, this is the exact logic you need to write training robots, pretty much exactly like this. You need pulls, sometimes loops, and you need if and else, exactly the same stuff. So if second pass points to false, then we'll have current val 2 points to I, or equals to I. Then we'll have current sum points to current val plus current val 2. So it's going to add them. The current sum is going to be current val plus the value of current val 2. So it's going to add them together. Then we update our boolean here, so we say second pass points to true. So I might end up just doing these again later in C line, just so that we can walk through the debugger properly for those learning loops and stuff. So we have second pass points to true, close the if. I'm kind of lost here too. So we had first pass is equal to true, just stepping back. Close the bracket, then else, open, if second pass is equal to false, open bracket, current val 2 points to I, current sum equals current sum plus current val 2, second pass is equal to true, close square bracket. Okay, now we got another else clause, so nested conditionals, which is good practice for any language. We have else, another else clause, current val points to current sum, semicolon, so that's it. Current val points to current sum, new line, and then current val 2 points to I, new line, and then current sum points to current sum plus current val 2. So current sum points to current sum plus current val 2. Then we have 1 square bracket, 2 square bracket, 3 square bracket. That didn't work. Sorry. 1, 2, 3. Then underneath, printf. We'll call printf sum in quote in string. %d, new line, and the string comma. Then we'll call current sum here. Close the parentheses, semicolon. And the closing of the function. I think that's it. Because in C files, it's just each function has its own block. There's no bracket at the bottom for the whole source file. So it just subdivides them by, like in other languages such as Java, we have another closing brace below for the whole class. But in this instance, we don't. We just have the source file. Each function is itself. Main is itself, and for function. Main doesn't loop around everything. There's no class here, basically. There's no class at the top to loop around everything, so each is just a separate function. So this pretty much is the main file. I named it wrong, but that's okay. What else are we going to need here? So void for function should be everything. We have the for, and at the end we have our print, so that should be fine. Takes two parameters. We have loop, our variables, then we have the loop. Everything is in the loop. Then we print, and that should be the end. Now we have to prototype it above main. So pretty sure I've gone over this so far. If you guys are watching the tutorial if you're watching this, if you have been watching from the start of the tutorial series, from this video series. That's wrong. stdbool.h. At the top, stdbool.h, and then with the closing angular bracket. Hopefully you guys did that properly. So now we're going to have to prototype it above main. So here we'll type void for function, open parentheses, int val1, int val2, close parentheses, and then we have to add a semicolon at the end. So here we can call for function we can pass in like the values 1, 4. So now what I'm going to do is I'm going to want to save everything here, so I'm going to go back to commands, to the command mode, I believe. So I'm going to go to the command mode, I'm going to hit escape. So I'm going to hit shift semicolon W, and this was we're going to type the file name, so for function.c. So then it says we have an alert at the bottom. It says for function.c new 44 lines, 634 bytes written. So then we'll say we'll just say WQ just to resave it just in case, and quit. So now what we can do is we can hit ls. We have our for function.c, right? But I don't believe we've moved. We're still in the home directory. So what we can do is we can change directory. So we're going to change directory to C codes because I believe we're in the home directory right now. we'll hit, we'll type in cd C codes. This should move us to that directory. So now it tells us, okay, we're in home, we're in /home/ or /home/kali/C codes. So now you can see that we moved from the home directory to the C codes directory. So if I type in ls again, oh, you know what? Oh, I don't think we when I made the function, I didn't we didn't go into C codes. So we didn't type in cd C codes before we made that file. So now it's just sitting in our home directory. That's okay at this point. So we can later on we can move it if we need to into that folder. So now let's compile it. So you guys have already installed GCC. I believe we did that command at the beginning. So let's just compile it and then execute it. So we type in GCC, that's the command. File name, so FOR function. So it's camel case and then .c. What should work? We have our file name for function.c right there. Oh, you know what? We're in the wrong directory, so we need to go cd home. No. Root. No. CD. Need to move to trying to get out of C codes. Change directory to CD. Let's check an ls. Oh, we're still in there, okay. Oh, okay, where are we at now? Okay, so we're still here. Let's type in pwd cd home /. Okay, I'm just gonna quit this editor and just come back. So we'll just reopen that. Okay, so that there's two terminals on here. One's like the root one, and one's the terminal emulator. I believe one's like technically one's for more administrative stuff. You could do more with it. One's just kind of just for files. We were in the root terminal. We can try going back to that one. So we'll just go back to that one. So here it's gonna ask for your password. Alright, so what we can do here is we can, I'm just going to zoom in because that text is so small. Okay, so we'll just say ls. With nowhere. Okay, so we'll just say. Okay, so we're not going to use this one. We're going to use the other one. There's some kind of, it's a little bit funny sometimes, so we'll just stick with this one. I'm not a Linux expert. Like I just had a class or two on it, so we'll be using it more in the future. Basically, I just know like the here and there's of it, so we'll just try to work with it. So we'll just stick. So my main focus is pretty much software. So I don't do too much administration. It is in my program though, so they just kind of got us to do one class on it. We'll be using it later with networking and firewalls and stuff, so we'll talk about it later. So we'll just do ls again. Okay, so we're here. So now let's try to compile it again. So what we're going to do is we're going to type in gcc again for function.c. Okay, I believe it was compiled so because there was no error. So what we can do is we can now type in dot backslash, I think it's a backslash, so dot slash a dot out space. Do we need that? Okay, so it did work. So you don't need to type the file name after you type in dot slash a dot out. You don't need to hit space and then the file name. It already knows you. It already knows we compiled the for function.c and then we've now executed the file with that command. You don't need to type the file after a dot out. I think maybe you can. It might work as well. That's alright. So now what we're going to do is the code worked. So that's good. There's no errors in the code. Now we can generate the object. So now we can generate the assembly code. So x86-64 assembly code for this file. So I think we can do that with gcc -c space dash capital S for function dot C. So now we have for function dot S. So what we can do, I think, is we can say vi for function dot S. There we go. So now we're viewing the assembly code for this file. Sorry, for the C file we just generated, we coded it. The loop, the one with the loop, the for loop. We have the file is so there's a lot of extra stuff in here. A lot of macros. A lot of people might be looking at it like gibberish. Pretty much it is, because it has its own macros that's the problem with it. It has a lot of built-in macros that aren't really that aren't part of it. It seems like they're almost hidden. If they're almost hidden, like if we type in, we may do a bit more analysis of assembly code in the next video or in another video. But pretty much if we just do a print, like a hello world, and then print it, it has all these kind of weird macros that it doesn't really explain. Like if you actually want to print hello world in assembly language, it doesn't require all those macros. But anyways, this is it pretty much. So basically we have in our main, so these are registers, like these things. So these things with the percent sign are registers. So what assembly does is it moves all the information onto the register to the memory itself. So it's pretty confusing. I don't think I'm going to be getting into it today. A lot of these seem like macros that it just hasn't really defined. It's just kind of stating them. So these things in blue are commands. So what happens is it says, okay, we're going to push a quad word, which is like a quad word is like it's like a primitive type that can have a certain amount of bytes. I don't think you even need the Q on it, so basically just push RBP. Then what it does here is it moves. So I think push is going to push it onto the stack. They're going to have MOVQ, so it's gonna put RBP stack. It's going to put the RBP register onto the RSP register, whatever's stored in the register. Then here it's going to move. It's going to move 4 into ESI. So those are different registers. It's going to move those values into the register. Then it's going to call the for function. So when that happens, call for function, we go to for function. So wherever it is, they're here. So for function, that's the what's it called? Subroutine. So it's called a subroutine. So for function, then it goes, okay, we're going to push RBP into the stack again, and we're gonna switch these. We're gonna put the RVP, whatever values are in the RVP, into the RSP register. They're gonna put the RSP, whatever's in the RSP to. We're gonna subtract whatever's in the RSP register from 48. Then here it jumps to L3 after it does that, so it moves everything, subtracts that value there, jumps to L3, so we have to go to L3, the subroutine L3. So then it says, okay, we do this. So here, move, then CMP means compare these two, move this onto that, I believe EAX onto whatever it was in RVP. Then compare EAX with RVP. So it's going to compare it. Then if it's going to jump if less than. So if the comparison is less than, jump to the L7 subroutine. So we're going to have to go back up. And if it's not, so what happens basically, it's like an if. So it's like an if or else. So if it's not less than, then it's going to continue down. So this line gets skipped. Then move here, move there, call that. Basically, that's what's happening here. So we jump. It's like a bunch of conditionals. So if we did jump to L7, if it was less than, we go back up here. Where was it? Up here. I forgot what test means. That command. So if we jump, so if we jump equal, so if these two are equal, I believe, we jump to L4. If not, we continue and then jump to L5. So you guys get the idea. It is confusing, to be honest. You need a lot of practice with it, which I didn't get because they just threw it at us at the end. So anyways, this was the first Linux tutorial. So we covered a lot of stuff here. We covered the commands to move around the directories. We'll probably move that file on later on in the next one into the other folder. Then we'll move all these files into the C codes folder. So what we've done is just to summarize, excuse me. So we basically told you guys how to install Linux at the beginning. Then we did the command sudo update sudo apt install to install the vim or vi editor. We also installed GCC, I believe. We then went into the vi editor, talked about how to save, quit, save and quit, save without quitting, all that. Talked about, before that we talked about command mode, insert mode, how to get into command mode, which is escape, and then how to get it into insert mode is press I. And then once you got that down, we created some files with the vi editor. We went vi space, that vi space file name opens the vi editor and creates the file and opens it with the vi editor. We then created the for function file, wrote the C code, compiled it, did the commands to open it. So once we saved it, we compiled it, I believe. Then we executed it. It worked. Then we finally created the object code for it, or the assembly code. I think we also went over some commands in just Linux commands in the directory. So we went over make directory, we went over ls, list files and directories, mkdir, make directory, cd, change directory. And then pwd, present working directory. So we went over those commands. Clear, maybe we went over clear as well. So cat space file name, we didn't do that one, but that just displays content. Whatever file to the screen, so it just prints it. So for now, that's a lot to go off for now, so we'll continue with the next one, probably moving the files and writing the rest of the codes. We may do some more commands, and then we'll just leave these tutorials for later on and we continue with it. May not get that many videos right now, just for the series may just be like 4 or 5 videos to start, and then later when we continue with other stuff we'll add to them. We'll probably go over the rest of the directory commands, and then we'll continue with the assignment. We'll type the rest of the codes and then compare the assembly codes if we can. So hopefully you guys enjoyed the video. If you guys want to see more videos on coding or anything, trading, investing, bots or whatever, you can subscribe to the channel, and I'll see you guys next time. Take care.